For lesson 89, we're going to be estimating square roots. So we've practiced finding square roots of perfect squares from 1 to 100. In this lesson, we will find the square roots of perfect squares greater than 100. We will also use a guess and check method to estimate the square roots of numbers that are not perfect squares. As we practice, our guesses are going to improve and get better, and we'll begin to see clues to help us estimate. So example 1 says simplify the square root of 400. So what we need to do is find a number that, when multiplied by itself, it has a product of 400. So we know that 400 is more than 10, because 10 times 10 equals 100. We know that 400 is much less than 100, because 100 times 100 is 10,000. So then let's look at the 4. Since the square root of 4 is 2, and the 4 in the 400 hints that we should try 20. And 20 times 20 equals 400. Therefore, we find the square root of 400 is 20. Okay. So we're just kind of using clues in that number to help us shrink down our guesses. Okay. Now, simplify the square root of 625. So in example 1, we found that the square root of 400 equals 20. Okay. The square root of 625 is greater than the square root of 400, so we know that our answer is going to be greater than 20. Okay. We can find that it's less than 30. Okay. I'm going to use 30 as my next guess. It's nice to go by tens. But 30 times 30 is 900. Now if we look at the last digit in 625, it's a 5. So we could try 25. It's between 20 and 30. It ends in a 5, so it should have something to do with a 5. So we tried 25. They showed their work there. We find that square root of 625 is 25. It's 25 times 25 equals 625. So we practice finding the square roots of numbers that are perfect squares. Now we're going to estimate the square roots of numbers that are not perfect squares. So it says between which two consecutive whole numbers is the square root of 20. Notice that we're not asked to find the square root of 20. Okay? Because I'll tell you, it's going to be a long decimal. We're not going to be able to find the right answer. Okay? So what we're going to do is we're going to find whole numbers on either side of the square root of 20. Okay? And we can first think of the perfect squares that are on either side of 20. So they showed you the first few perfect squares starting with 1 all the way up to 49. Okay? So we see that 20 is between the perfect squares 16 and 25. It falls right in there. So the square root of 20 is between the square root of 16 and the square root of 25. Okay? Since the square root of 16 is 4 and the square root of 25 is 5, we see that the square root of 20 is between 4 and 5. So our answer is going to be 4 and 5. Okay? Because it wants what the square root is. And we're going to write two numbers, the smaller number and the bigger number. Okay? They got to be consecutive numbers. We couldn't have 4 and 6. Okay? It says two consecutive whole numbers. So, using the reasoning in example 3, we know that there must be some number between 4 and 5 that is the square root of 20. So if we tried 4.5, we get 20.25. So it's a little too big. You try 4.4, it's a little too small. So it's greater than 4.4, less than 4.5. We continue it. We never find a decimal or fraction that equals that square root of 20. Okay? Why? Because it's irrational. Irrational numbers are numbers that cannot be expressed as a ratio of two integers. Okay? Remember, integers are a set of counting numbers, their opposites, and 0. So -2, -1, 0, 1, 2, so on and so forth. Okay? Another example of an irrational number is pi. It's a number that contains an infinite number of decimal places with non-repeating digits. Okay? We talked about how pi never ends. 3.14, it just keeps going on. It can't even be put into a fraction. Another example of square roots of whole numbers that are not perfect squares are 21, 150. Okay? Square roots of decimal numbers may or may not be irrational. For example, square root of 2.25 is not irrational because it's 1.5. 1.5 times 1.5 equals 2.25. Okay? The square root of 22.5 cannot be expressed as a decimal that ends or repeat, so therefore it's irrational. So rational numbers are numbers that we put into a fraction or the decimal ends. Irrational numbers we can't put into a fraction, the decimal doesn't end, it just goes on forever. So irrational numbers cannot be expressed exactly as a ratio or a fraction or decimal, just like I said. Okay. So when we look at the square root of 20, it's about or approximately equal to 4.5. So we use these two kind of squiggly marks to show that it's about or approximately. So it says use a calculator to approximate it. If I pull out my calculator here, square root of 20 is 4.472136. So it ends, so it is rational. We can see, okay? So on the practice set, there's a lot of problems. I'm going to do letter D for you because those are the tricky ones. It says those are the ones where we have to find between what two consecutive whole numbers. So I see the square root of 2. Okay. Now, let's think of the perfect squares. I know 1 is close to 2, and I know 4 is close to 2. Our perfect squares. Square root of 1 is 1. Square root of 4 is 2. So since 2 is between 1 and 4, the square root of 2 is going to be between the square roots of those 1 and 4s, which is 1 and 2. So I show the answer here. Notice it says 1 and 2. Okay. The way I like to show my work is either like this, or I have, so I have my 2, I have 1, 4, square roots are 1 and 2, my answers are 1 and 2. So go ahead and try these. My guess is you're probably going to have questions. Okay? Make sure you bring them to class so we can go through this. If you have questions, you need to ask, especially on this, because these are going to come up. You're going to see them a bunch. We need to know how to do them. Okay? If you have a calculator, great. Do the JK and L. If you don't, skip them. Not a big deal. Okay? Like I said, make sure if you have questions, you bring them to class so you can ask them. We can get them answered for you.